Okay, 13.2, define general angles
Oh, I forget.
and use radian measure.
I don't. And I need to restock my money.
Ouch. Are there a lot of those?
Examples?
Yeah.
I have 4 pages.
It wasn't even an excuse, I literally said I agree.
Okay. 4, 3 through 5, they give us problems. So I'm going to draw them all out so that we can see them. So we're going to do all of these ones. Don't die, Addie. So problem number 3 is negative 240 degrees. These are matching problems, so that's why I'm doing it this way. Number 4 is 600 degrees. And then 5 is negative 9 pi over 4.
Alright, so I'm guessing. I don't know what I'm guessing.
So, and then option A. I'm going to draw all of these
We
out.
have to draw this.
You don't have to. If you want to, you can, but
Thank God.
these are all in the book, and I'm just going over them so that I can explain so you're not as confused about what we're going to be doing shortly hereafter. Okay. Option A.
I'm guessing B is 240.
Oh, I like that one. It says
All right, some of this is probably going to make a little bit less sense at the moment because we haven't done the unit circle yet, but I'm going to give you a little, I don't know if this was in your notes or not, but just as an example here, okay, this is 0 degrees, whoa, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then all the way around is 360 degrees. Okay, like if we had a circle on here, that would be the whole thing.
Wait, so C is like 8.
As far as if it's in radians, this is in degrees. I'm just giving you a very basic rundown. This is 0 radians. This is pi over 2 radians. This is pi. This is 3 pi over 2. And all the way around is 2 pi. Okay? So, that's just kind of your general little rundown here. These will make more sense once you have your unit circle before the next section or with the next section. But
What's a unit circle?
You'll find out.
I'm so glad you asked. It is 66 things that you have to memorize.
Oh,
So 270.
actually, you know what? I don't really know what a unit circle is.
Welcome back, Dylan.
This is the unit circle.
We have to memorize that.
Well, that's the thing with
Yep.
couches,
Oh, I
man.
remember them.
I don't want to do that.
So,
I remember.
I'm giving you a very basic rundown right now because you don't really need all of that information to be able to do this, but you need a little bit of it. All right, so I'm taking these and I am picking which one is which. So, if it's negative, okay, that means that I start here and I go down and around, okay? Or I would start here and go down around and go backwards, okay? You go clockwise if it's negative. You go counterclockwise if it's positive. So, negative 240, okay, that would be going all the way around, or going halfway around, that's negative 180, and a little bit more, okay, so halfway around and a little bit more would be this one. So this would be B. And then positive 600, well, that's bigger than 360, so that means it would be going around more than one full time.
So we see.
So all the way around once is 360 plus a little bit more. So this one is C. Now, as far as the radian values, okay, all the way around one time is 2 pi. Okay, so if I wanted that as a common denominator fraction, 8 pi over 4 would be the equivalent of 2 pi reduced, correct? So I know this is a little bit more than one time around. It's negative, so I start by going down. So all the way down and around, one full time is 2 pi. and a little bit farther would make it to the negative 9 pi over 4. So this is A.
That works, I guess. My brain.
Mom, I don't know what to tell you.
Okay, draw an angle with a given measure in standard position. We're not going to get super specific. We're just going to get it in the approximate right area. Okay, so number 6 is 110 degrees. So I'm going to set up a little coordinate thing here like I had in the last one. So I'm drawing approximately what this looks like. So technically speaking, these spirals that were on here just show you which direction it was going and how many times around it was going, okay? The line, this blue ray here, is actually my angle, okay? So when I do this, this one's positive, so I start by going counterclockwise. So it always starts over here. I know that to here is 90 degrees, and then there's 90 more degrees over here.
So it's just a little more.
This is 20 degrees more, so that means that my actual angle is going to be somewhere in here. And basically, to draw it, I go from here to here.
Oh, so cute.
8. 45 degrees.
So like
Yep, exactly. So this one is, if 90 degrees are in here and it's positive, halfway between would be my 45. And so this one just goes from here to here.
oh, it's so baby. It's like mommy and baby.
It is a lie.
Talking about
Daddy.
the works. Oh, see it.
10.
Like a
Over a
week.
week. Since last Sunday.
This one is going to be 6 pi. Okay? Again, it's positive.
So you're on 3 times, right?
Yep. So, to here is 1 pi, 2 pi. I'm going to actually draw this out. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi.
Wow.
So this one is just
Around is a pi.
right here. All the way around is 2 pi.
So, one,
Halfway around is 1 pi.
so,
Alright.
You do 3 circles.
So basically it's 3 circles. 3 little loop-de-loops.
1, 2, 3, 4, 5, 6.
sounds like the heart from multi-million.
Addie.
Addie, I'm telling you.
Oh.
Addie, I'm telling you. Stop talking.
Once we've done our unit circle and stuff, we'll talk a little bit more about how they work in radians when I tell you, like, you're going around, like, 4 pi over 3 or something like that. But essentially, whatever the denominator is in radians is how many pieces half of it is broken up into. Okay, so if it's, like, pi over 3, it's broken up into 3 sections, like 3 slices of 3 slices of pie. And so it's like broken up, but that's like the top half. Then the bottom half is also broken into 3 sections. But we'll talk about that more when we do our unit circle. So I'm not doing any of the other ones as far as in radians. The other option that you have is to convert. We're going to be doing conversions of degrees to radians and radians to degrees. And so once you know how to convert radians to degrees, you could also do one that's in radians like this. Approximately once you convert it to degrees. But we're going to skip those for now until we've done our unit circle. So, anyways. The next thing says to find coterminal angles. And it wants a positive one and a negative one. So coterminal angles are angles that essentially the values of them would be equivalent. It's just the angle like themselves is like bigger or smaller. So what that means is I could look at it this way. So the value of this, like of 6 pi, would be the same as 0. It would be the same as 2 pi the same as 4 pi, and then obviously 6 pi. Okay, so it's increments of adding 360 degrees or adding 2 pi. Okay, I'm assuming that was probably in the notes, but. So, if I give you, find the problem, 16, it is 255 degrees. So I'm going to find this by, it's in degrees, either adding 360 or subtracting 360. And sometimes you may have to do it more than once. Okay, we'll have some that the number that they give you initially is so big that we have to subtract until we can get down to it. So 255 minus 360. Now obviously this is going to give you a negative number. So we've got, this is going to be, let's see, I'm going to flip these because it's easier to do this way, but
105.
yeah, just doing this so you can see. It's easier to see it this way. Now, you have your calculator, you can obviously just type them in and find them that way, whatever. Then we need to add 360, so we've got 255 plus 360. So 615 degrees. So this is my positive one, this is my negative one. Now, obviously I could add 360 again, and I could get, my next number, whatever. But what I want you to do so that everybody's answers look consistent is I want you to find like the least positive one and the least negative one. Okay, now least with negative is a little confusing, but like the first negative and the first positive one. Okay, does that make sense? So I don't want you to go be like, oh, 975 is the next one and like tell me that's the answer. Okay.
So that's all for them?
Yep.
Oh, that part's easy.
Co-terminal is probably going to be your favorite thing because it's just adding and subtracting 360 or 2 pi. 18, 820 degrees. So, because I know that this one is greater than 360, okay, obviously I know I'm going to have to subtract it off. I'm probably going to have to do it more than once to get to my negative one. As far as finding a positive one, okay, I can add 360 to this, or even subtracting 360 is still going to give me a positive value. So there would be a few possible answers that would be like acceptable for you to give me, okay? I would recommend, to save you time and less effort, is that you subtract, but that's up to you. So I could do 820 minus 360, and that would be 460 degrees. So this is one option for a positive one. I could also do 460 minus 360 and get 100 degrees. That's another option for a positive answer. And then I know I need a negative one, so I'm going to subtract again. So 100 minus 360 is negative 260. So that's an option for my negative one. I don't want to go any farther negative, but the other acceptable positive one is for you to take 820 and add 360, and you'd get 1180 when you do that. So this one kind of has like, even though I say like the least positive one, it's, somewhere within that general vicinity. Like, don't keep adding 360 at this point, but that's just more work for yourself. So, anyways. Questions about that before we get into radians? Okay, cool. All right, 20. Negative 7 pi over 6. Okay, so in radians, we're adding or subtracting increments of 2 pi. Okay, so plus or minus 2 pi to do that. Now, I see that this one is a pi over 6 value. So that means that if I want a common denominator to easily add my fractions, right, then I would need to find something over 6. So what pi over 6 would be the equivalent of 2 pi?
12.
Yeah, so I'm going to be adding and subtracting 12 pi over 6 because that's the equivalent of 2 pi with what I'm dealing with. So, negative 7 pi over 6 plus 12 pi over 6 would give me a 5 pi over 6. So that would be one of my that would be my positive option. Then I need to subtract 12 pi over 6, because even though this one's already negative, I still need a negative one. It tells me to find one that's negative as well. So negative 7 pi over 6 minus 12 pi over 6 would be negative 19 pi over 6. So that would be your negative one. Another one in radians, 20 pi over 3.
Oh my goodness.
So, what fraction would I be able to use that's equivalent to 2 pi, but that is a pi over 3 value? Yep, 6 pi over 3. So I'm going to be adding or subtracting 6 pi over 3. Now, again, I would recommend, because I see that 20 is much bigger than 6, I'd probably just start working by subtracting, but that's up to you. 20 pi over 3 minus 6 pi over 3 is going to be 14 pi over 3. So that's one option. I can subtract another 6 pi over 3, and that is 8 pi over 3. That's another positive option. Can subtract 6 pi over 3 again and get 2 pi over 3. That's another positive option. This is why I said I wouldn't necessarily add, not that you can't, but just already have a lot. So either of those three are good positive options. The other positive option is to take and add 6 pi over 3 to 20 pi over 3 and get 26 pi over 3 as another option. Up to you. All of those would be acceptable positive options. Okay.
So we don't have to write all those. We can only write one.
Yeah, but you're going to basically end up having to still subtract off 6 pi over 3. Now, if you recognize that you could just, that's way bigger, you could multiply 6 pi over 3 by a number and then just subtract that off as well. But all of those are acceptable positive ones. I still need my negative one, so I'm going to take this 2 pi over 3 and subtract 6 pi over 3 and get negative 4 pi over 3. And that would be my negative one. So what you're going to see, okay, what this is leading us into is when we go around our unit circle, all of these values would be hit at the same exact spot on our unit circle, okay? But we obviously haven't done all of that yet, so. My next thing is converting degrees to radians or radians to degrees. So obviously whichever one you start in, you're going to the other one. As a general rule, not so much that it happens in this class or even in this section, but later on it will start to come up potentially more. Degrees are always going to have a little degree symbol on them. Okay, radians typically are going to have a pi in them. Okay, so all of these values that we just did are radians. They have pi's in them. If they don't have a pi in them, okay, then you're going to see the letters RAD for radians. Okay, again, doesn't happen a whole lot in this class where they give you a value like that, but it can. So I just want you to be familiar with that. But if there's not a degree symbol, essentially you can assume it's radians if that's what you're dealing with. So 24, we have 315 degrees. So you should have had some conversion factors in your notes for degrees to radians, radians to degrees. The conversion factor is basically, I make a little T-chart to do this because it's just easier, but it's pi over 180 or 180 over pi depending on what we're dealing with. But I need to cancel degrees, so that means I need those things opposite, so it's going to be pi over 180 because degrees cancel. Now, we don't actually multiply the pi through, okay? Most of the time, these things will reduce nicely into a fraction or something like that, but again, you get your calculator, but do not multiply the pi through. The pi should be in your answer, Okay, like you should see the pi written there. So I'm going to go ahead and write it so they don't forget it. 315. Oh, actually, I'm going to show you this little trick on your calculator. We may have done this before, I can never remember, but I always assume in this class that you haven't done a whole lot with your calculator, so even if you have done it, you probably need a little bit of a refresher. So I want to reduce this. Now, I can obviously sit here and I can take and I can reduce these things on my own. I could be like, oh, well, I know I can take out a 5 because one ends with a 0, one ends with a 5, and I can work my way down, and that might be all I can take out, but I'm not sure, whatever. When they're easy numbers, I'm going to just do it that way a lot of times. But 315 divided by 180, your calculator is going to produce a decimal value for you. Okay? So what you can do, if you want it as a fraction, because we want our radian values in fraction form, is I'm going to hit math, so over here on the left-hand side below alpha, and you're going to see, I call this dart frac, and the reason I say that is because that's what Mr. Cass called it, and that's what stuck with me. But it's a little arrow, and then it says frac. You're going to hit that, and that's going to take your decimal and turn it into a fraction. 7/4. So this would be 7 pi over 4 would be your answer. Huh?
Not in the fraction.
I said you don't multiply the pi through. It goes in the fraction.
You like, yeah.
26, 500 degrees. So, again, this is degrees. I need radians then, so I'm going to multiply by pi over 180. So, with this one, I'm going to not use my calculator, okay, because I want to make sure you've seen this trick before. I'm sure you have, but just in case you haven't, when I have two things that both have a 0 on the end of them, I can cross out the 0. And I now have essentially 50 pi over 18. Well, both of those are even, so I'm going to take out a 2 from both of those. And so when I do that, 25 and 9, is there anything else that can come out of those?
Nope.
So this one is just going to be equal to 25 pi over 9. So they're not always the prettiest, like, numbers at the end, but that, I mean, that's just what we're working towards. Now, when we get to using these things in a problem, we obviously will have to multiply the pi's through. But as a general rule, when we're converting degrees to radians, you leave the pi in there. Radians to degrees, 28. Pi over 9. So I want this one as a degree. Now, I need you to watch this one very closely, okay? So I have pi over 9 in my chart like this. Both pieces do not go on top. If you put them on top, you're going to get confused and get the wrong answer, okay? The pi goes on top, the 9 goes on the bottom, or whatever the number is, okay? Now, I use my conversion factor, but instead of it being pi over 180, I need the pi's to cancel, which basically eliminates my radians, so it's going to be 180 over pi. So my pi's cancel. 9 goes into 180 how many times? 20, so this is just going to be 20 degrees. 30. 14 pi over 15. So again, 14 pi goes on top, 15 goes on the bottom. I'm going to multiply by 180 over pi. This one isn't necessarily going to cancel out as nicely, but the pi's do cancel. If the pi's don't cancel, you set it up wrong. So eventually you will figure out, how all this works. But you'll just multiply 14 times 180. Okay, so you multiply across the top, divide away the bottom, and then divide by 15. So 168 degrees would be the answer to this one. We can't do the rest of that yet. Okay. I don't know if this was in your notes because I don't remember when I did the notes if I had like added this because I normally was doing this later. So anyways, this if you already have this written down, you don't need to write it again. But if you want to or you don't have it written down, you should write it down. Arc length is the formula S equals R theta. Okay. Now, I'm going to highlight this thing. Theta is in radians.
Not beta.
No, not beta. Theta is in radians. Okay, that is key. If it is not in radians, the problem will be wrong. Okay? Not because I want to mark it wrong, but because the formula does not work if it is in radian or if it's in degrees. It only works in radians. Then the area formula is either A equals 1/2 R squared theta or A equals 1/2 R times S. So if you have already found S as your arc length, I would use this formula. Okay, this is the easier formula to use because this is already accounted for the R theta in here. Anyways, up to you, but I will use this one for area probably 95% of the time. So 32, what? No, she was asking me a question. R equals 4 inches, theta equals pi over 6. So, you're also going to notice that these values have units on them. Okay, if they have units, we have to put the units in our answer. Okay, so this theta is already in radians. Okay, it's got the pi, so I know it's in radians, so I'm good to go. So first I'm going to find my arc length. So S is equal to R times theta, so 4 times pi over 6. And you're going to get a decimal value. Now, I think you've probably found it by now, but above the caret symbol, okay, above the division, you're going to see a pi symbol. You have to hit second and then the little caret. It's below clear. You can't find it. You have to hit second in that, and that will give you your pi. Don't just type in 3.14. Okay? Use the pi symbol. So you'll have 4 times pi and then divided by 6.
Wait, am I stupid? I can't find it.
It's below the clear
Click
button.
Second, and then click the caret button above the division symbol.
The button that looks like this, Addie.
Oh.
Caret. Click the second.
I did. What are you? I
You
clicked
just straight up
second.
took the
I clicked
calculator.
second and it didn't work.
No one believes you.
So 2.09, we're going to round to 2 decimal places, and then inches. So that's the arc length, okay? Now, in case you don't understand what arc length is, think about the crust of your pizza, okay? This is what you're finding is what is the distance, essentially, of the crust of your pizza. So,
I had pizza on Sunday.
now the area then
Congrats.
is 1/2
Really good.
R times S. So R is 4, and then we multiply it by the S of 2.09. Now, before you click anything, you should still have this 2.09 on your calculator from when you did it.
Yep.
I can
Okay.
go back though. It's okay.
So once you have this, now obviously this is an unrounded answer. It's not gonna, if it's gonna change your answer, it's gonna change it by like the second or third decimal point, not enough that it's gonna be a big deal, okay? You're gonna just hit whatever the next symbol is. So I'm gonna multiply it by 4, and notice it says A and S, that's for answer, times 4, divide by 2, and it will give you the value that you're looking for without you having to retype in the number. Now, can you retype in the number? Absolutely. But you don't have to, because that allows you to just keep what you had previously found, okay? More important in science when you need like your significant figures and all of those things, that you may or may not know. But anyways, when you need all of those things, it's important that you can use that in your calculator. So area is equal to 4.19, and then this one is inches. Area has what kind of units? See if you remember.
Squared.
Squared. Area is squared. So arc length is 2.09 inches. Area is 4.19 inches squared.
Shut up.
34. R equals 15 centimeters. Theta equals 45 degrees. All right, what's the problem with this one?
It's not.
Yeah, what he said.
It is not in radians. Now, what I'm going to tell you is 45 degrees is a value you're eventually going to know from your unit circle. Right now, you do not know that. You will after either tomorrow or Thursday. But right now, you do not know that. So we're going to use our conversions, and we're going to convert from degrees to radians. So, 45.
Oh, whoa.
What in the world just happened? Okay.
You gotta do this.
45 times pi over 180. How many times does 45 go into 180?
9.
No,
I don't know.
It's
4.
4.
Same thing.
How do y'all do that?
I was thinking 9.
What is
at one
45
point.
plus 45?
90 times 2.
90?
No, that's 90,
90 times 2 is.
Yeah,
180?
I was thinking
Oh
28.
my.
So, in radians, this is pi over 4. Okay? So that's the value I have to use. If you use 45, your answer's going to be wrong, and it's going to crack me up. This is the mistake everybody makes, is they leave it in degrees. Do not do that. Be the class that makes me happy.
Not like geometry.
Should have put that angle.
S equals r theta, so 15 times pi over 4.
11.8.
2 decimal places.
Oh, sorry. Then 11.7.
So 11.78, and then we got to have units, centimeters. Then area, 1/2 RS, so R is 15. S is that 11.78. Again, you can just use the value from your calculator. If you use the rounded value, again, totally fine, up to you.
Oh, this is a big number.
88.36.
Aw.
Oh.
Units,
Centimeter squared.
centimeters squared for area.
That's a big
Not
number.
All right.
huge.
Any questions about this?
No.
All right, so this is basically all that's in this section. Okay, now there is technically a little bit more to this, but it requires us to have the unit circle. So what I think I'm going to do is tomorrow I'm going to give you a work day. Okay, you have a little bit of time now. If everybody finishes early tomorrow, we may start the unit circle, but I need about 30 minutes to do the unit circle because I don't want to start it and stop it and all of that. So, because I'm going to very much in-depth explain the unit circle to you because you've never seen it before. So, most likely Thursday we'll do the unit circle, but we also may start the next section. But there's a few problems. There's about 8 problems of this section that we are not doing yet because you have not learned the unit circle. And so I don't want to do them if you don't have it because then you're just going to be confused. So, anyways, so problems up to where we are right now. And again, you'll be doing these tomorrow.
It's got 20 on one.
It's probably going to feel like that, but they're actually not that bad.
Oh, yeah, tomorrow.
Julia, make sure you're writing down these homework problems.
All right. 7. 15. 17. 19. 21. 25. 27, 29, 33, and 35.
Brian's gonna be tomorrow's.
And that is fine. You have tomorrow to do it.
May I go pee?
Today's